lefty-righty. So this is free fall, which is basically the exact same thing we've been doing before, except instead of going lefty-righty, things go uppy-downy. Well, really just downy. So things go downy. Doop-de-doop-de-doo. This is a cool video. You should go find that, because you get to see that dude dropping a hammer and a feather, and they land at the same time, and there's no weird science, he's just in space. So it's pretty cool. Okay, boop-de-boop-boop-boo. Did you know that things fall due to gravity? So basically what we're saying here is, instead of the other problems where we could have like, oh look, sometimes it's accelerating with a equals 12 meters per second or blah blah blah, here we always have this value. Now, yes, there are like technically blah 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 blah, but in physics we always assume the cow is spherical at 1 atmosphere and can be represented by a particle most of the time of almost no mass. Anyway, so for that purpose, we pretend that the acceleration due to gravity is 9.81 meters per second squared. And you're like, what about wind resistance? Yeah, y'all aren't ready for that yet. Wind resistance is for like the big giant kids, and we're on the little kid playground still, with like where the moms can, you know, be like really really close in case we, you know, fall off of something that's very small. That's where we are right now. So basically the most important thing is to know that if you're doing stuff in metric, it's feet per second, and if you're doing stuff in the other one, in imperial, it's 32.2 feet per second. The 3 sig figs are important, and of course sometimes you see these equations where they're automatically negative, but just remember that it's a direction. So yeah, if you define down as positive, which is a thing that can happen, then acceleration would be positive. If you define down as negative, then acceleration is negative. So for the most part, probably to make your life easier, you're always going to say going down is negative. But just know that one day you'll get to a point where, for sometimes, just to make life quote unquote easier, down will be positive, in which case gravity will be positive. Okay, because it's accelerating downward. Okay, so one-dimensional motion involving gravity. I would like to rotate my mouse, please. Oh, I know what's happening. Okay. Here we go. Okay. So basically, it's the exact same equation that we had before, except they do this stupid thing where they do this. Whoa. Whoa. Whatever just happened needs to unhappen. So let me go back to where I was. Whoa, we went really far down. Okay, so I actually don't recommend looking at these at all, because they're the exact same thing that we had before, except they have this minus GT, and then don't do that. Just, it's gravity. Gravity points down. So if you're going in the negative direction, then yeah, gravity is negative. I mean, you know what I mean. Like, let me just show you. Like, if we're assuming it's positive, stop memorizing like multiple equations that all mean the exact same thing. Just learn one equation and it's fine. Okay, so let me show you kind of how we're going to mess with this. Okay, so we have this ball, blah, 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 blah. It has an initial velocity downward. Okay, what is the velocity when it hits the ground? So we can do this already because, and it's from a 98, whoa, something building. Okay, so I did get a new pen. I don't know if you can tell. It's very exciting. Okay, so we have this thingy. We have a height, and so we have 1/2 AT squared plus V naught T plus X naught. We know that the final height is 0. The acceleration is downward, negative 9.81. See how I didn't have to have a special equation for this? It's the same equation as before. And then my initial velocity is 4.9 downward. The other good thing about doing it this way is it makes you realize, okay, I also need a negative on the velocity because the velocity is going downward. The velocity and the acceleration are both going downward, so they should have the same sign on it. And then that has plus an initial height of 98 meters. And so really, now that's all I have to do. And I feel like when I was in physics that they gave you all these extra things to make it less confusing, and it just ended up making it more confusing for me. Negative 9.81 divided by 2. So that's my 4905. Oh, I forgot the T. So negative 4905 T squared minus 4.9T plus 98 equals 0. And yeah, I'm probably going to shove that into a, what do you call it? You know what I could probably do is I can probably do t squared, well, times t squared minus 4.9t plus 98 equals 0. Can I do this? I can. And then I can use my algebra, you can't see that, algebra, solve this for comma t. And if you don't know this, you can always use the quadratic formula, but there are my two values. So t can be, obviously it's not happening negative 5 seconds ago, so it's happening 4.00 seconds into the future. Okay, awesome. Now what's the velocity when it hits the ground? We go to our v equals v naught, or let me keep it in the same order that I always do it. V equals at plus v naught. So we know a is negative 9.81 because it's pointing down. We know t is 4, and then we have the initial velocity, which is negative 4.9 because it's going down. Does that make sense? And so that's why I don't like having that negative g in there, is by me having to remember that acceleration is negative, then that also makes me remember, oh yeah, I've got to make sure I've got the right direction on velocity or whatever. So negative 9.81 times, and then 3.99819 minus 4.9 and negative 44.12. So velocity is negative 44.1 meters per second. And yep, that's the same thing they got there. Awesome. So you see, these aren't too bad. It's pretty much the exact same thing you've already been doing. It's just specifically with gravity. Vertical motion of a baseball. How many of these are there? Should we make this a separate video? Rocket booster. Okay. We'll do these here because we're only at 7 minutes, and you can watch or not watch because that's the joy of science. Okay, so a batter hits a baseball straight up, and it's caught 5 seconds after it's struck. What's the initial velocity? What's the maximum height? Okay, so we know that. Ooh. Okay, so we know we've got Tadoops equals 1/2 at squared plus v naught t plus x naught. And that's for both going up and going down. I don't know why I'm writing this twice. I just feel like I need to, because I'm trying not to look at these before I do them. Okay, so what is the initial velocity? Well, on the way down, it's going to go shoop, and then it's going to stop, and then it's going to come back down. So on the way back down, we could say its final height is 0. We call this 0. It's 1/2 negative 9.81 t squared. Its initial velocity on the way down is 0, I guess. And its maximum height is, we'll just call that h. 0 times t, but it's just 0. Okay, does that kind of make sense? So this is the time down, which is going to be different than the time up, which, you know, that's not great, but let's find something here. All right, now over here, he ends at height h, 1/2 negative 9.81 t going up squared plus some initial velocity, I don't know, t going up, and he ends up, on his start position is 0. Let's see. Okay, so I went through all of this, and I'm leaving this on the page because I want to show you that sometimes I get in my own way because I'm trying to be clever, and then my brain breaks. So I was going up and then down, and then I had too many variables, and I couldn't figure out the whole thing, and my life was broken. Okay, so I want you to see all of this mess that I did. So eventually when you do the mess, you'll be like, that's okay. My professor does a mess too. Look, professors are just like us. Okay, so... Okay, I'm gonna try again. So, where I went wrong, or not wrong, what I did was fine, but I did up, and then I did down. And I ended up in a situation where I had way more variables than I could do anything with. And I forgot that instead of just doing up and down, I could do up and down as a set, if that makes sense. So in my brain, I was totally fine going up and doing the math, and then I was fine going down and doing the math. But then I could also write equations for up and down together. Okay? So this is actually really important because, like, for example, in my ups, see, these are all like time going ups, and these are all time going downs. So those were all different, and I was running into this problem, and I got an imaginary time for an answer, which is obviously terrible. So let's take this as a moment to remember that we can also do something called up and down together. So if I have this 1/2 at squared plus v naught t plus initial, if I start it up, or if I'm starting at base and I'm going back to base, then my x here are both 0. And that actually makes everything infinitely easier because I know that the time here is 5, my v naught, and the time is 5, and then that's it. And I don't have to do all the crazy stuff that I was trying to do, thinking this problem cannot possibly be that hard. And it wasn't. I was just overthinking it. And that's going to happen to you a lot, and I'm sorry, and there's nothing we can do about it. And that's just life. So here I get an initial velocity of 24.5. And that was super easy to get once I knew what I was doing. And so this is the thing, it's like, how do I say this? Don't panic and, well, first of all, don't cheat, because, like, well, once I know the answer, I know how you got it. Well, duh, like, that's the easy part. But also, like, it's the struggle and the going and the experiencing the frustration and then figuring out what you did and then that kind of thing. So I just wanted to show you that I went through all that and then realized I was being crazy. Okay, now that said, I can also then come up with the idea that on my way, say, up, I have that v squared equals v naught squared plus 2a, let's say, x minus x naught. And this is just on the way up only. Okay, so think about whenever something goes up, it's going to stop, and then it's going to come back down. So your final velocity on the way up is going to be 0. I have my initial velocity, and 2, negative 9.81, and I don't know my height that it gets to, but I know I start at 0. And so now I can do some math. 24.5 squared divided by 2 times 9.81, and that gets me a height of 30.7 meters. Okay, so on the way he hits it going up that high, it ends up going that high, and then what is the velocity when it is caught? So whenever it is caught, we can now go down only and be like, okay, so if it's going down, velocity final. I wonder if I can do it this way. Velocity initial plus 2a x minus x naught. But here, my final velocity, I don't know. My initial velocity is 0. It's 2a negative 9.81. And then it starts at, it ends at 0, and it started at h, which I happen to know what that is. That's 30.7. So I've got 9.81 times 2 times 30.7 and then the square root of that. And so I've got 24.5. So V is going 24.5 meters per second on the way back down, which that seems a little too perfect, but that is apparently right. So, okay, notice that I put it, that's the velocity. The book is listing it as having a negative velocity. And I feel like that is I think this is because this is physics and I'm thinking about this as an engineer, as the velocity of the ball is 24.5. But if I was going to be making a vector called the velocity of the ball would be negative 24.5 j hat. Does that make sense? So I think for the purposes of this class, you probably want to indicate negative is down, but just if it helps you maybe doing it differently than maybe listing things as vectors of like, okay, it's negative j hat means it's going down. So there you go. Well, that was unnecessarily complicated, and I'll, in the interest of time, I'll let you just go ahead and look at this. I think this is basically the exact same thing, doing it again, and then we'll get into the next section.